This is a animation introduction to the resistor capacitor lab. And before I describe what's going on, I just want to show you this animation. So this animation represents a pretend circuit. There's a battery and a resistor, and then a new thing called a capacitor. So a capacitor represents two parallel plates of metal that are separated by something. It could be air or something else that does not allow electrons to skip across it. I have a switch here which allows electrons to flow or not, depending on if it's open or closed. So right now it's open, that is, electrons are not allowed to flow. When I close it, watch what happens. The battery pushes electrons through the wire, it pushes electrons through the resistor, and then the electrons build up. And I know the resolution might be a little poor, but there are negative signs on this right parallel plate, and there are a bunch of red plus signs on the left parallel plate. If I open this switch, that prevents the battery from pushing electrons through the circuit. I have a lower switch here that if I close, electrons move along the lower wires. More precisely, the negative signs leave the right plate, move through the resistor, move clockwise through the switch, through the wires, and when the electrons collect on the left plate, they cancel the positive charge, and that leads to a neutral plate on both sides. So watch a couple times. The negative and positive charge build up, and then they cancel out. So that behavior is the first example we've seen where something is changing in time, and it helps to visualize how the charge looks on the positive and negative plates. I can do that by attaching a voltmeter. That is, this is intended to be something similar to like the green box in lab, where you have a black and red clip, and the target signs here represent the red and black clip. I can attach it to the positive and negative side of the capacitor, and watch what happens when I connect the battery. As the positive and negative charge build up on the two plates, the potential difference, the voltage, builds up. So you have this literally exponential behavior. And as I open the top switch and close the bottom switch to discharge the capacitor, the voltage goes down as the plus and minus signs disappear. So this charging process and discharging process is described with an exponential function. Those are provided in the lab handout. We'll be using that in our lab. And how quickly charge builds up depends on the strength of the capacitor. A stronger capacitor will take longer to have the charge build up. It also depends on the strength of the resistor. A stronger resistor, in a sense, you can think of as slowing, the electrons will move slower through that resistor, and that will also lead to a longer charging time. Again, that description of how long it takes for the capacitor to build up charge is mathematically described in the lab handout. There's a specific mathematical prediction, and we will be building a circuit similar to this and testing that mathematical prediction. The circuit we build in lab isn't going to be exactly like this, because this is a slightly dangerous setup. It's dangerous because if you close both switches at the same time, you get fire, and we wouldn't want to have fire in lab. So we have a slightly different setup that is safer. Let's stop there.